This one.
Yes, ma'am. Once again, laboratory work. Laboratory work that we are doing previous time, last 2 weeks, and you are going to do it now to finish. Actually, there are two different laboratory works, and um, in contrary, that you have seems like one report, but you have it in 4 pages. You have 4 pages in this report. One page with picture and empty place for diagram of assembling. Backward, you see, да? Back side. Also, diagram of locating chart and empty place for diagram of assembling. And you have 2 pages each with technological process. What is the difference? Actually, the item to be assembled and laboratory work today finally we suppose it to understand the jig arrangement and the process of manufacturing this final shape of this spa. That is spa of center wing. What is center wing? I hope you do remember. There is compartment of wing, which is between the left wing and right wing. It may be inbuilt in the center of fuselage. It may be under the fuselage. It may be over the fuselage, whatsoever. It's central compartment of wing. And this central compartment of wing typically has the same structure as wing. It has front spar, it has rear spar, and frames between them. Whatever spar is this, front or rear, above the all, you should do imagine the airplane and you recollect must be that it's your group. Yes, some days ago I dropped you here photo of Antonov 72. Oh look, what это? Look, where is the center wing? Center wing in the middle between left and right spar. As you might see, for instance, almost practically to the center wing, the engine nacelles are joined. Maybe that, no, not better visible here. No, this photo is more talkative. By the word, why it looks so weird and why I dropped it to you. In order you might see it unpointed. I hope you do remember that airplane before it's proven, let it be confirmed by the customer that customer agree to take it. Airplane usually not painted into so-called suite of companies that going to buy it. In Russian we call it, in Ukrainian, in Russian, whatsoever, we call it livreya, like suit of servant. And in English it's called suit. The coating which correspond to the colors of company. Here it's unpainted airplane, you see. Where the center wing, I already said you. And this center wing, it's symmetrical usually. You see airplane and you understand that it's symmetrical mostly. So what you see here in the picture, it's a half of a spa in laboratory work, in laboratory class, and in video explanation that you supposed to watch before class. Remind you, before class, before, even 2 weeks ago. It's a symmetrical picture, and that is why you see only the half. On the left, on the right, it's completely the same. So when you are explaining something in diagram of assembling here, you suppose it to remember that you have two halves, and maybe you need to use names like left one, right one. Here you also have top and bottom. Also, you need to remember that you are working with top, bottom, left, right. Pay attention to the next fact. What you need to do. You need today to compose technological process of hanging the element of junction units, so-called elements of junctions. What are elements of junctions in your case? There are big brackets on back side. Here you see, approximately you see. You will see it in a photo and you have seen it in video. In case you watched this video, lazy bones, I'm already got tired to swear you to
Mom, I
this.
watched the video.
Oh, you pleased me. It's just balm on the wounds of my heart, really. You can't even imagine. Uh, if even you do not understand what is it there, I'm happy to hear that at least someone followed the task. Look, big bracket. You have little brackets in front immediately that we usually call knife because they are formed, we call it knives. And also you have engine mount brackets, these little side brackets. All these brackets must be located onto spar, must be assembled all together with spar only in a jig. Why we were talking about in the subject in topic junction at the beginning of semester. The axes of these brackets, the axes of holes in these brackets, they determine position of another aggregates next with respect to each other, because if you place bracket wrong one or another, these side brackets for engines, what may happen? Engines will have different heights or different orientation of axis of engine, or they will be unjoinable at all to this damned wing. And it means that your airplane lost flight performances. In case these side brackets that you might see I forgot where should I show something? Well, in ODEM. Да, laboratory class report. Ага, вот он. In case this side... Что ж ты творишь? In case this side bracket holes does not correspond to the same in the wing is not joinable, so on. And importance of axes of hole is so great that they are compulsory, all the parts with GPH, they are compulsory located only in a jig, in contrary to the spar itself. This spar, which consists in turn out of web, caps, and stiffeners, you may assemble preliminary and not compulsory in a jig. It was up to you, what you decide. Whatever you decide next, you reflected here in the diagram. It's called assembly diagram. In the diagram order of assembling. Here today you suppose to compose final diagram of assembling, which includes the previous one that should be here, which includes the previous one as a sub-diagram. I hope you do remember that the diagram of so-called parallel sequential assembling. And in order to understand what you are starting with, what is the diagram, what is the first part here, and what are the names of part, you need to watch the video. And I also said that I'm going to show you the materials that you have seen in a video, actually. No? The materials been used with previous group in order to help you, which is drawn here the names, and these names you are recommended to use. You may use it. If you'd like to use something else, you may use something else. To remind you what diagram of assembly look like, here you see diagram of assembly. It's block scheme. Looks like algorithm of program, no? And that one correspond to assembling by assembly holes. What is assembling of assembly holes? I hope also you do remember. It's in the picture a little bit higher. It's aligning of preliminary made holes in some parts. And due to this localization, finding, searching position of parts with respect to each other. In this case, a web, is, as it showed, web has system of assembly holes for top cap, for bottom cap, and so on. If you'd like, it's not compulsory to do it like this. If you'd like, you may assemble the same. No, there is the same picture, but by pieces. Seems like, yes, yes. If you'd like, your highnesses, you may assemble it in a jig. And here is already another stage of explanation, a bit later, not now. Вот. Да, here is. Let's rotate it. Да. If you'd like, you may do the same task, assembling the spar in a jig. Pay attention what jig looks like. Practically, it comes about such plates, the system of such plates. It's very similar to what you were doing in your very first lab, assembling the spar. But there it was readjustable jig. If you may insist that you have readjustable jig, you may insist that you have special jig for this spar assembling. It's jig without hanging the brackets yet. It's just jig for locating the web, the cap, and so on. The most primitive jig ever. 2 pins, no? And some locators. Some it's several. No? It comes about, let it be 1 locator to 1 meter. Around 4 locators will be enough for this part in order to provide the accuracy of outer contour. And it's another diagram of assembling that you may see here. What is changed? The order maybe has changed of assembling. Instead of web at the first place, it has appeared system of caps. And now you see that in a diagram has appeared jig, in contrary to what we, to what we have seen before, when we have web at the first place and no jig. In this picture, you see jig has appeared, and web is somewhere in the middle, according to order of their locating in a jig. Well, let's see some photos to recollect what do we have. Here you see the end of spar, this end of spar. You see knife, one knife, another knife, and pieces of brackets that is under the part. Next, this by itself, we can't see it from both of sides simultaneously. We see only web now, cap, top cap, bottom cap, and one of stiffeners. On back side, you have quite the same stiffeners. Pay attention that stiffeners are in front of each other. That is the first ever problem that you have. And pay attention that stiffeners, by the word, from both of sides, they have so-called joggle. They are made from sheet, not as we get used to, not off extruded profile, off sheet, but anyway they have these joggles. You see double changing of backside in order to be attached both to the web and to the cap surface. No, just some more photos. That is top bracket, this little side bracket for engine mounting. Not for engine mounting, it's one of element of engine mounting. Don't think that the whole bracket, the whole engine may be like clamped down, pinned to the airplane with this little needle-like bracket. Some photos explain you structure of the jig. Now you see this bracket immediately. Yes, and you see locating onto jig. Now let's try to talk about what is the process in progress. Let's see, do we have the whole picture of jig or not? Practically yes. What you see the jig from one side, like along the jig. And once again, remind you, jig is symmetrical. It's not visible backward, the back side of the jig, but it's quite the same as here. It has symmetrical portion of locators here and there, and it has symmetry at this place, and little bit far to the middle also has symmetry. Pay attention how many locators it has. So exactly as I said, 4 locators are enough. And it has 1 locator, second locator, third and fourth. Don't forget that in the case if you assemble, if you bring in here already pre-assembled spar, it's already pre-assembled. Another side of pickups, it's not for locating, it's only for clamping. Yes, there are couple of pickups, but bottom portion of pickups it's used for locating from both of sides, and side bottom of pickups, this vertical portion, it's used only on one side. Usually we attach, press, locate the spar to this side, to us. We are staying from this side and we like pulling it to ourselves. Students, when they're in class, they remove everything from jig, they destroying jig and next contracting it again. No, it looks like this because everything is accompanied with noise, with occasional droppings of pickups or occasional droppings of heavy parts to the feet of their mates. Joke, never happened such thing. No one feet has been broken in our laboratory class. Well, and what we have to do? We need to align all the elements of SPA using locators of jig. And what is all the elements of SPA? They are the SPA itself, which already consists from half of dozen of parts. I hope you understood. Bottom brackets, big one, this couple of knives on this side and on that side, and side brackets. We need to find their mutual position with respect to each other and fix them in this position. Actually, the most of work, 3/4 of work in real life, it's not locating. It's exactly about making joints. Because whilst making joint, we don't do it in class in real. In order to do qualitative holes, you have a lot of work to do. You have, no, really, it's headache. You have to drill holes together first by a template or by conductor, or at least by pilot holes, by guiding holes in the first part. For instance, you see part here, but holes in knife, and you need to drill together knife, spar, and bottom bracket. This big side, big bracket, you need to drill it together by pilot holes. Let it be by pilot holes, because jig has no conductor. If you'd like, you may insist that you have template, for instance, somehow to attach it here in the jig to drill. But more simple is preliminary to have holes in top part for knives in our case. And this part will serve as a template until you assemble. What is next? After you drill holes together, after this, if even there are holes for rivets, you actually need to countersink it a couple of times. And better, of course, to rim it even, but at least to countersink it. It means that each hole you are passing thrice. First with drill, next with countersink of one diameter, another is with countersink of a third diameter. I hope you do remember, I'm not asking you in order not to waste time, I hope you do remember that these additional steps of cutting, especially when it comes about countersinking, rimming, we are doing to increase accuracy, to improve accuracy of these holes. Because in contrary to the drill, countersinker has more blades. More blades, it means less step between blades. Less step between blades, it means more accuracy when cutting. Rimmer, they have even more blades. They have dozens of blades already, and it means that you have extremely accurate cutting, and together with this extremely accurate cutting, you have extremely thin cutting, because it's cutting only very thin layer. It comes about some hundreds of millimeters when it comes about trimmers. When we're talking about countersinkers, they are usually cut in a range 0.10, 0.5 millimeters of the of diameter, not more. Well, it's if riveting holes for rivets. It's very simple. If it comes about the holes for bolts, and mostly you are dealing here with holes for bolts, it's even worse, because you need to pass 2-3 times with countersinker and 4 times with rimmers. Why like this? Proven in life, proven by experience of engineers. And it comes about so-called tightened bolts. Tightened bolts, it means that they are intended to extend their fatigue life. They must have good fatigue properties about the wall. Well, watching too long for this picture. As I'm already said, first problem, how to locate it, and next problem, how to make joint. How to locate it? What locators we have? We have, wait, what? Here it's better visible. We have locator. Now you see this far side of the jig, this symmetrical far side. we have locator of these big GBH holes. Где она? И где она? А вот она. Где она? Ну, неважно. Look at this. These holes, they are not in work at all in this laboratory work and this stage of assembly. When I say we have locators of big holes, what I mean? I mean these two holes. You see, hole in knives, both in knives and in bracket. Oh, да. And you see it's like layered pie, да? The bracket, next spar, and next knife. Holes are, of course, only in bracket and in knife. I hope you see it. And you see that how they are located. We have some element like bar with holes. Actually, it looks even like handle, not just a bar. And in order to align holes, you align and clamp parts. You placing here the pin on one hole and in another hole. Why the third pin? What it's necessary for? Actually, this locator is openable. It's rotatable. Why? When you insert parts into jig, when you locate part into jig, it's not a problem when locator place it like this. When after assembling of everything, you will try to remove, or do imagine that you remove this pin and that pin. May you remove the spar through locators? Of course not. And that is why you need remove at the end stage. You need to remove pins, all pins from spar and from locator itself. And next you need to open locator, rotate the handle to this side in order to remove spar after assembling. That is why it's rotatable. It was one locator, another locator of GBH where we have little spar. Here is this locator, you see it, да? Aside of spar, we have this red element. It's supposed not to be red actually. Red color, it's only mounting elements. It's element of second order tooling. The one who repaired the class until all teachers were absent in summer. Someone has, as I already said, you have painted elements of jig in bright, colorful colors without thinking about the real meaning of these colors. No, the one who have no any relation like to our industry just made repairing in class. Looks brightly, greatly, but wrong. Jig must be colored, painted into grayish colors, greenish colors, blue, no, something like this, but certainly not in yellow, not in red, because these colors belong to only to tooling of second orders. Yellow, red, orange, all those things, they are for movable elements of machine, and they are for tooling of second order. Even colors should talk to us. What one more problem is here in this lab? We are not solving this problem, but at least we are talking about it. What might happen when we locate the spar? I'm already said we have couples here of locators. And it may happen that when we pull this spar to these locators, we compress spar, clamp it closely to locators on backside. Here may have appeared the clearance. Like I show here, you see the gap, clearance between bracket and the spar. It's inappropriate. But for those who read the explanation and manual, it's already well known that actually, because we have dispersion of sizes, so-called range of sizes, tolerance, may happen two situations. No, in one maybe 2 cases out of 100 may happen ideal situation where all sizes are ideally fit. Once per 100 of cases, maybe less. What about, no, like the middle, да, of this distribution of sizes? What about other cases? There are two possible variants. Either this part has clearance or these parts overlapped. Overlapping, it's even worse. Primary basis, in this case, this axis of locators, of GBH locators. We must not attach bracket to the spar. We must preserve this axis above the all. What if we have clearance? Clearance we may fill with some another part, with another additional material. What if we have overlapping of parts when we can't fit the place, the bracket into this place and insert the pin? It means that we should cut bracket on backside or cut spar or cut bracket on backside, reducing the strength of this bracket, breaking the protective coatings and so on. It's inappropriate completely. And how engineers usually solve this problem? It's in addition to what we were talking when we talked about assembly method with limited interchangeability. What does it mean, this assembly method with limited or non-completed interchangeability? That we are using allowances and tolerances, or we're using compensation. Here we're going to use compensation. On purpose, before we start assembling, we are calculating dimensional chains in such a way that we compulsory have only clearances, but we can't guarantee that this clearance will become 0.1 millimeter or 0.5 millimeter after manufacturing of all the parts, after some stages of assembling. We can't say what will be the final clearance size. That is why we don't know what thickness of the part. Here must be inserted one more part, little pad, no, something like washer of the same shape as backside of bracket. We can't say what is the thickness of it. So in the process of locating, when we see that we have clearance, and remind you, we have calculated dimensional chains in such a way in order exactly to have clearance gap, but with unknown thickness. First, we are measuring the thickness of this clearance. Next, we are not cutting any part. We're just filling the clearance between bracket and cap with some layers of foil. No, bracket in our example is made of steel, spar made of aluminum alloy, depending on, moreover, it's not our decision. It's reflected, this decision is made on the stage of designing of the spar. Of course, it was made according to wishes and demands of manufacturers. It means that following this approach of DFA design, design for assembling, we have studied last year, I hope you do remember, so-called technological efficiency of structures. According to this idea of DFA design, designer already have thought forward, in front, let it be, of this problem. He have calculated these dimensional chains, he or she, whatsoever, and in a drawing, in this place, it's visible some thin parts, and in technical specification in the drawing, it's given that these parts, thicknesses, and the amount is determined during assembling. So you are measuring the clearance, and next you insert here some layers of foil in order to compensate this clearance during assembly. Because position of axis is more important than position of one of caps of spar. Well, no, what you might see here in photos, I will send you these photos. I'm not think that they are much talkative to you, these photos, but I will send you. No, as I'm already said, you see brackets here, you see pickups, they're typical design. I'm sorry that you never played with it. Sorry, in a class, it's very joyful process for students usually. You see one side, another side you have already seen, symmetrical pickups, 4 times from one side, 4 times from another side. It's with to locating chart that you are going to develop. And that we have already talked. You see beginning of assembly process. This handle, this side locator of GBH now is opened, and you see that no any bracket, no any knife at the end of spar yet. First, we are going to close it. What we are closing it, as you might see, until this hole aligned with this hole in locator. Now you see that I'm trying to insert. I was talking, making record and clicking photos. That is why we have this set of photos. Let it be. Yeah? You see that we have here in my hand. You see the bracket under my hand, and I'm trying to show that we are going to align these big holes. What now you see that bottom bracket is located, and even knife located already. No, they are not located yet. Located when everything is aligned. I'm just showing what must coincide. These two holes and this hole. Finally. Finally, we are closing everything. Wait. What you see, what it looks like now. Layered pie, as I said you. Inserting the pins. Here you see what holes are aligned. I may check it with finger, but they are not clamped yet. Now everything is aligned and both clamped. But again, this layered pie is clamped with pin. Finally, we have located it. How it's reflected in your technological process? It's not beginning of process. It's already on fifth or sixth operation, because beginning usually start with prepare the work in place, check completeness of parts, check absence of damages of parts, open how many locators supposed to be opened and which exactly, and so on. You're explaining what work in place should looks like before you start, which tooling you need to check, what you need to do it all. Next, you need locate the spar, pre-assembled spar, into jig by 4 locators, clamped with 8 clamps, and so on and so forth. Next, close side locator, no? For instance, close side left locator. Pin it, clamp it with pin. Repeat it for the right side, because I hope you do remember that whatever you have on left side, you need to repeat on right side. Now you see the right side of jig actually. Locate big bracket on the locator of GBH, on the side locator. Locate left top knife to the side locator and pin it with, clamp it with pin together with big bracket. Locate left, right. Locate right bottom knife together with by GBH, together with big bracket onto locator, side locator, onto side GBH locator, clamp it with pin together with big bracket. Repeat item number, whatever item. No, you are writing it in technological process. You have numbers in items. Repeat previous item for, and next you explaining names of parts, exact names of parts. Left big bracket, left top knife, and right top knife. That was operation of locating. Ой, извините, что-то я не туда крутанула. Here you see the general view of the jig, and this one, left side, right side. Next, you need to go back to these creatures, no? Locate, bracket, side bracket, or how you call it, little bracket, top bracket, locate top bracket. No, it's necessary to write down specification around of picture and next follow to the specification, path list, no specification, path list. Locate top left bracket onto locator of GBH for this bracket, clamp it with pin. Next, I hope you do remember what might happen. Clearance. Measure the clearance between backside of bracket and this cap of spar. Calculate amount or select the thickness of pad, insert pad, and now clamp it. Pay additional attention to the fact that clamping here, the composition of jig, let it be, now the design of jig, doesn't give you opportunity to clamp something here. It means that clamping here will be with not elements of jig, but with additional, they call it screw clamps or C-type clamps. They looks like letter S, and they have side screw. If necessary, I may remind you, they are in explanation of our first lab. The same problem you may meet at this place. At this place now you see it without brackets, but when we see it with brackets, look, when we insert everything, might be somewhere the photo. What there is the photo why I made this photo actually. Pay attention. Knives are aligned normally, like they are parallel to the spar, and here maybe not ideally visible, but here you see clearance between spar and this bracket. It's significant clearance because bracket it's very heavy. It's now it's like hang it only on this place, on this support, but under its own weight it deviates from spar to the bottom, and it means that you need also additionally clamp it. Where you may clamp it to? Only what do you imagine when we have everything here already, only to this place or to the web? To the web, it's not reliable. Web is very thin, so you may clamp it. You may place here additional clamps to this place, like C clamps, when you have both knives and brackets here and on this side either. But problem is, as only you pay attention by the word that amount and location of holes is different at the top and at the bottom. Diameters of holes and so on, they are different. Pay attention that as only you placing here C clamp, some holes became unreachable for you. You can't have access to these holes. And it means that, and actually in life it's compulsory, such a thing. First, you are attaching temporary clamps, C clamps. Next, you are not drilling all the holes, you are drilling a couple of holes, and the farthest holes usually. No, if we're talking about short place. For instance, you will drill these holes and drill hole, and into these holes you will insert temporary screws or temporary pins, or maybe even these clicks, if the diameter of hole correspond to nomenclature of clicks that you have in the shop. In order two pins in holes of structure hold all the element of structure together, and next you may remove C clamps which overlap access to the another holes, and you may continue to drill another holes. That is such a moment in this laboratory work. No, in explanation everything is given, do forgive me. What you also should pay attention to. No, practically we have already discussed everything what is possible, guys. Once again, first you are locating this spar into first you are preparing the jig. Next you are making sure that you have all the tooling, that you have all the parts undamaged and they correspond to the specification to the part list. Next you checking that all clamps are opened. All clamps, it means that you have opened 8 clamps of these pickups. You have opened 2 side locators and you have removed pins from little bracket locators. Next, Your Highness, sorry. After you located and clamped the spar, you comes into locating the brackets. Not this one. This one. Close side GBH locator, locate big bracket, locate knives, clamp it with pins, clamp it with pins, repeat for another side, for symmetrical side, and please don't forget to locate here, to locate little brackets to their places, to measure the distance between bracket and spar, and to insert the part. Actually, what I was talking right now, it was order of assembling. Pre-assembled spar, next big bracket, knives, next little brackets and pad. In general, it's the order of assembling, but in order of assembling, you have different names. Where to take these names? Not that one. No, in such a picture, for instance. You have it in the explanation. These photos I will drop you, but I will copy it from another group to you, and I will drop to you into your Telegram chat these photos. And the next procedure, it's explained in videos, that is why I'm not going to explain it once again. It's procedure of making joints. You need to fulfill some bolted joints, some riveted joints. Riveted joints, if you'd like, you may fulfill immediately at the place, or to go out with this spar together with brackets already pre-assembled to riveting press, if you'd like. But bolted joints you need to do immediately in a jig compulsory. And each time making the joint means that first, what do you first? What you do first? You need to prepare the hole. In most of cases, it comes about sometimes of first drilling, next countersinking, next trimming. Next, you need to remove, you need to clean parts. It means that you need to dismantle some parts in order to have access to inner surfaces. To dismantle some parts, to clean them, and from these blunts, clips, chips, flashes, whatever. After cleaning the parts, you need to locate everything back into jig. Make sure that everything is aligned perfectly and start inserting the elements. Before you are inserting the fasteners, you need to clamp. I hope you do remember, more firmly than it was during locating. You need to insert temporary fasteners in 10-15% of holes. If you have 10 holes, you need insert at least one pin, or better 2 pins. 15% of 10 holes, it's 1.5 pins you can't insert into drilled holes. That is why either one hole or 2 holes. No, practically at each side where you have knives, you are inserting couple of temporary fasteners, either pins or technological screws. Next, you start procedure of inserting the bolts and tightening the bolts, and next you continue procedure of riveting and finishing up everything with coating of heads of bolts and painting the special inspecting lines, let's say red colored lines on the green enamel head or gray enamel head, very well visible in case nut or bolt rotates, and start untighten it a little bit, unscrew it. In this case, you will see that that red line is broken. You will see it visually while inspection between flights. And In this case, it's necessary to stop flights and to start repairing procedures. That is why they are painted in such weird way. Let it be. Well, right now, questions? No questions. Guys, are you here?
Yes, ma'am.
Sure. As you know any questions, I hope you understood that previous time you have filled this page and this page. It means like assembling the spar either by assembly holes or in a jig, this spar without brackets. You once again you have locating chart to draw here. You have here the assembly diagram, order of assembly, and technological process. What you suppose it to do. And here you see you have like outer lever, like shelling of this. You see that you have something like shell. First page and last page. In the first page you have locating chart. I recommend you to write down all the names here, and you supposed to do it actually 2 weeks ago. Assembly diagram, it's empty place. In order you might draw something like this nightmare. Oh, without pictures, of course. It just and it's not assembly diagram for SPA with brackets. It's assembly diagram only for SPA. I hope you understood it. It comes about the assembly diagram either in jig or by assembly holes in the previous lab. And today, of course, you are working only in a jig. I remind you that at the top you have Centerwing Spar. Next you have oval with name jig. And next in the order of assembling you have all incoming elements. And you must follow the standard, what it looks like. It's determined by standard. Don't invent, please, your appearance, your owner appearance of diagram of assembling. You must follow the standard. It looks like block diagram without tricks, please. And next you need to compose here technological process. Mostly it comes about joining because the most complex elements of this process are joining, and about locating we have talked in detail. If no any another questions, we are stopping the record. Any questions right now about lab? There are only few present, let's see. Questions? Azhelik, Brinta, Godwin. Pradiv has said that he has no questions.
I don't have any questions, ma'am.
Azhelik, Godwin, questions about lab? Don't make me cry. Godwin, are you here? Or maybe Godwin is sleeping. Okay. Yeah, let's stop record.